Hello friends, in the last several videos I would say, we have discussed about physical quantities and units, correct? When I say length of an object, it is to be measured in meters or centimeters or millimeters or kilometers, right? Or then time you measure in seconds. Uh, Mass you measure in kilograms or grams. But then uh, basically for measuring you need some measuring techniques, correct? For example, if I have to measure length of uh, this object, correct, I have to measure start from here and here, so I have to find the distance between these 2 points. So generally what we make use of some measuring instruments. In this case we would be using a meter scale, correct? You can use a small, for an object of length, something like 15 centimeter, you would be using a small scale, or then a 30 centimeter scale, correct? What you see on the scale, you see centimeter marks, you see millimeter marks there, you on the other side you see inches marks, correct? So I can use a foot scale or a 15 centimeter half foot scale for that, correct? What about measuring height of this room? For this I can make use of measuring tape, the kind of tape the carpenters use. But then if I am standing in under a huge roof, okay, and the height is more than, let us say, 30 foot or something like that, correct? So what would I use over there? Can I use that meter tape, which measuring tape which that carpenter uses? It would be difficult, because as I unwind the tape and start moving it further, okay, the other end it should touch the ceiling, correct? But then by the time I cross about 8 or 9 feet, the tape is going to fall, correct? In such cases, what do? Over there we need some different measuring techniques. For example, I might use some ultrasonic device. It's a small device, even smaller than maybe 5 centimeter by 5 centimeter, and you just have to press it, you just have to put it on ground there and press a button. Now what happens over there? An ultrasonic wave travels from the instrument to the ceiling. From the ceiling it gets reflected, it is received back. Now the time taken by the ultrasonic wave to uh, hit the ceiling and come back, that total time is measured. Now my the device is placed over here, and this is a ceiling, correct? So the wave starts from here, it goes on top and comes back, okay? So this is a transmitter and receiver. The time is measured, okay? This is the distance t, time is t, correct? Now we know the speed of sound, speed of ultrasonic waves. It is about 330 meter per second. That is speed of sound in air, or in moderate air conditions. Okay, I know the speed, I know the time, correct? So my speed is equal to distance upon time. So my distance is equal to speed into time. So that is one way of measuring distance here. Over here I was using a meter rule. Over here I am using something else, correct? There may be different ways of measuring distance. For example, I'm standing here, correct, and there is a tree over here, correct? I want to measure the height of the tree, h. Now what do? Can I measure it? Can I use a meter scale or a foot scale or that measuring tape used by carpenters? No, obviously not. It would be very difficult. Now instead of that, what I do is I stand here and I use one instrument called sextant. Okay, I place it over here. I place it at some known distance here, known distance d from the tree. And then what I do is I measure this angle using that instrument called sextant. If this angle is theta, right? Now from the tables you know the values of trigonometric ratios, correct? Sin theta and cos theta and tan theta, you know, correct? So now what I do here, my tan theta is going to be opposite side upon adjacent side, so that will be h upon d, correct? Therefore h is equal to d into tan theta. For example, here if my angle theta measured here, okay, if angle is 30 degree, then tan 30 I know it is 1 over root 3, and I know this distance and I can easily find out the height of the tree. So rather than standing here using some measuring tape and making some inaccurate measurement, I would go for this, correct? So here the height is not measured, it is calculated by measuring something else, right? What about measuring distance between Earth and a planet, correct? Is it possible? Yes, people do that, physicists do that. How do they do that? Suppose this is our Earth, correct, and this is that planet. And how do I do that? Now here we would be using this, okay? If theta is my angle here and r is the radius of circle, and if the arc length is s, then s is equal to r into theta. This theta is in radian. Okay, radian is a unit of angle. Now s is equal to r theta is something that we would be using over here. Now here what I can do is I'll stand at point A and then at point B, correct? From A okay, this is my planet P here, okay? So I measure this angle here and then this angle here. Now how do we do this? We take one distant object here, some planet, and with reference to this I measure this angle phi 1, and then I'll call it S1 and S1. It is S1, okay? It is the same planet. I measure this angle phi 2. So then if you draw a perpendicular here, then this is going to be a phi 1 and this is going to be a phi 2. So my theta here, theta is equal to how much? It would be phi 1 plus phi 2, correct? This distance is known, d, and if distance between this planet and Earth, okay, it would be roughly same at this and this point and at this point, okay? Then if this distance is, let us call it d, no, d is this distance, so let us call this distance, let us say r, correct? Then my d is going to be equal to r into theta, using the same notations there, and then r is going to be equal to d upon theta, correct? So that is how we measure distances, okay? Now a distance between distant objects, okay? In the same way you can even measure distance between two stars, okay? One star is here, one star is here, and I'm here, okay? I want this distance. Using the same principle you can do that, you can do that, and that principle, it is called principle of parallax, or it is called parallax method. So measuring the length of this, okay, I could use a measuring meter rule or anything for that matter. Okay, I can use parallax method, I can use angle method like we did over there. Correct. Now that we did that tan theta, uh, we calculated using tan theta, correct? But then over there, that tree is something that I can see, that tree is, let us say, at a distance 50 meter or 100 meter from me. Okay, but then I don't know the distance. Okay, I don't know the exact distance. In such case, can we find out the distance again? Again, the uh, answer is yes. How can we do that? Now, for an inaccessible object, let us say there is this some mountain here, okay, and I want to find the height of this. Okay. Now what I'll do? Uh, I stand here, okay, use the sextant, and I get this angle theta or theta 1. Okay, then I move a distance, let us say d here. Okay, and I was at point A here, now I'm at point B here, and again I measure this angle theta 2. Correct. Now what is my, now this distance is something that I don't know, that is my x. Okay, now what is my tan theta 1? Tan theta 1 is opposite upon adjacent, so that would be h upon d plus x. Correct. And tan theta 2 is going to be equal to, again, opposite upon adjacent, so that is going to be h upon x. Correct. Now what do we do? What do we do next? I'll take reciprocal of these two. So cot theta 1 is equal to d plus x upon h, and cot theta 2 is equal to x upon h. Right? I know I have measured the angles, so I know the ratios. I know tan theta 1, I know tan theta 2, so I know cot theta 1 and cot theta 2. Correct. So I know the ratios. Now what I'm going to do is I'll just take the difference between these two. Okay. So cot theta 1 minus cot theta 2 is going to be equal to d plus x upon h minus x upon h. So is it not d upon h? Because that x upon h is going to get cancelled with the other x upon h. So obviously this distance x, which I do not know, I don't know the total distance between point A and then foot of this mountain. Correct. But then anyway that got cancelled there. Okay. So my height, okay, so my h is going to be equal to d upon cot theta 1 minus cot theta 2. Is it not simple? So practically we can calculate any distances. We can measure certain quantities and we can calculate distances. Okay. So that was about that was a brief about measuring some distances. In the next video we are going to learn to use some measuring instruments, and then in the subsequent videos we are also going to talk about precision and accuracy of measuring instruments. Thank you so much.